So we learned about the algebraic division in the previous video. We're now going to be looking at something called the factor theorem. So first things first, a factor theorem is used just as a quick and easy way of finding linear factors. So for example, for a quadratic equation, we know we can factorize, right? But for a cubic equation, it's hard to factorize, or we haven't learned how to factorize it yet. So instead, we can find factors using this factor theorem. So what the factor theorem is doing is basically it's like a trial and error method. So you plug in some values into the function and you're trying to get 0. So as you can see here, if you plug in some p values into the function instead of x and you get 0, then we know that x minus p is a factor of that expression. So let's try and apply this. So if I have a factor, an expression f of x, which is like 6x cubed plus 11x squared minus 3x minus 2. Okay, so we haven't been told what a factor is. We can't divide it by algebraic division because if we were to just randomly choose some factors, like divide this by like x plus 4 and find a remainder, then we're going to have to keep repeating the whole long process again and again until we find a remainder of 0, which is just time consuming. And so what we can do now is apply the factor theorem. So as I said, it's like a matter of trial and error. So you want to plug in some x values into this equation to try and make 0. So in most cases, you want to start off with x is 1 or 2 or x is minus 1, minus 2 and go from there. So let's start off with f of 1. Okay, so if I plug in 1 here into all the x positions here, then I will get a value of 12. So we get a remainder of 12 essentially. This means a remainder of 12, which means that x minus 1 is not a factor. Let's try minus 1. The same thing, you just plug it in to each position like this, and then you work it out and you get a value of 6. So once again, this is not a factor. You just have to keep going until you get 0. So if you put 2 in, we'll get 848 plus 444 minus 6 minus 2, which is 84, not a factor. Let's try minus 2. We'll get minus 8 minus 48 plus 44 plus 6 minus 2, which is actually equal to 0. So what we found out is if we plug in x is minus 2 into the function, then we get a remainder of 0, meaning that this is minus 2, x plus 2 is a linear factor of this function. Okay, so now we've identified the linear function, now we can go about factorizing, or we can divide it. Okay, so I can do algebraic division like we did in the previous video. So x plus 2, and we have 6x cubed plus 11x squared minus 3x minus 2. And just quickly doing algebraic division, 6x cubed plus 12x squared, get minus x squared minus 3x, minus x squared minus 2x, we'll get minus x minus 2, so minus 1 minus x minus 2 is 0, so this confirms that x plus 2 is a linear factor. This means that I can rewrite the original function f of x as x plus 2, well, it was originally 6x cubed plus 11x squared minus 3x minus 2. So I can rewrite this as x plus 2 times the quotient, which was 6x minus x minus 1. And now this is 6x squared, sorry. Now I can just factorize the quadratic term. So this would be 3x, 2x. What we're going to have minus 1 plus 1 like this. So now we can fully factorize a cubic term. This applies to any like power 4 terms, power 5 terms. We just have to find the initial linear factor, and then we can fully factorize it like this. So as you can see, it's just a matter of, the factor theorem is a matter of trial and error to try and get 0. That way we can identify our factors. Sometimes they might refer to something called the remainder theorem. The remainder theorem is exactly the same as the factor theorem. It's just another name for it, but it's just a case when we get a remainder. Okay, so when we get a remainder, it's called the remainder theorem. If we get a 0, it's called the factor theorem. That's just the difference between just the wording or the naming of these two processes.